Hi, in this video we are going to be finishing off the last part of the assignment 02 part 2. So the first part of this assignment was solving using the quadratic formula. The second part of the assignment, there's 4 questions that says to solve by factoring, but then our exponent is a 4 instead of 2. So these aren't quadratics. These are 4th power equations that we need to factor. But because this right here is the 4th power and this one is to the 2nd power, because that pattern is happening and there's no like 3rd term or there's no x term, we can actually treat this as a quadratic. So this is like the second part of 02 part 2. We're going to be solving by factoring, and this is called quadratic form. So it's not actually a quadratic because quadratics are 2nd degree and this is 4th degree. But because this has the basic form of a quadratic, we can still factor this as if it were ax squared plus bx plus c. So we're going to use like the same method. The only difference being that like when we factor a quadratic, we usually find the 2 factors that work and then we put x's here and here and we put our factors over here. Because this is 4th degree, when we find our factors and we put them in factored form, we're actually going to be putting these as x squared instead of x, so that when I multiply them together I do get my x to the 4th power. So we're going to do the exact same method, just make sure we put x squared here and here instead of x. So the very first thing I always want to do when I'm factoring is look for a common factor. And I can see that 3 and 54 and 243, those all have a common factor of 3. So my first step is going to be to pull out that greatest common factor. So if I do that, that's going to leave x to the 4th. 54 divided by 3 is 18, so 18x squared. And then 243 divided by 3 would be 81. So I'm just pulling that common factor of 3 out. So I will have a 3 in front of this when I get it in factored form. But now over here I can just kind of ignore that 3 and just look at what's inside the parentheses. A is 1 and C is 81. So I'm just going to x factor this. 1 times 81 is 81. And then my B is negative 18. So I'm looking for 2 numbers that multiply to 81 and add to negative 18. So 9 times 9 is 81. Also 9 plus 9 is 18. Because I want a negative 18, I'm going to make both of those negative so that when I multiply them, the negative goes away and it becomes positive 81. But when I add them, I would get that negative 18. So now let's go ahead and put our factors in over here. We would divide these by a, but remember a was just 1, so it won't change them. But actually, I just realized, so on your worksheet, it does say solve each equation by factoring, and this one is the same, but this should be equal to 0. So because it didn't have that in there, like the one on your worksheet does say that already equals 0. This one should have said it. So it actually is an equation instead of just an expression. So we factored it now, but it still equals 0. So now we can look at the different factors and we can find out what x values would make this true. What x values make these equal 0. So 3 is just a 3. There's no x with that, so that one's not going to do anything. It wouldn't make sense to say 3 equals 0 anyway, right? So the other ones with the x's in them, I'm going to set them equal to 0 and solve for x. These ones are both the same, which just means I have some repeated solutions. But I don't need to solve both of them. I'll just solve one of them and that will give me all the solutions. In order to solve this, I'm going to get x squared all by itself on one side. So that would be x squared equals 9. And then take the square root to get rid of the squared. And the square root of 9 is equal to 3. But remember, it could be positive or negative 3. Alright, so let's try another one. So this one, positive 3 and negative 3 would be the same solutions I would get if I solved the other side. Okay, so it means it has 2 solutions that are positive 3 and 2 solutions that are negative 3. but I don't need to write the same ones again, right? I can just say the solutions are 3 and negative 3. All right, so let's go ahead and try another one of these. So again, I have the 4th power here and the 2nd power here, and I don't have the 3rd power here or the x. So that's the pattern I need in order to actually use the quadratic form to solve this. So it's the form of a quadratic, even though it's not a quadratic because it's 4th power, so I can still x factor. On this one, there's no common factor between all 3 terms. So a is 1 and c is negative 54. If I multiply those together, I get negative 54. B is negative 3, so I'm looking for 2 numbers that multiply to negative 54 and add to negative 3. So this is going to be 6 times 9. Because my leftovers are negative, I want the bigger number negative, right? So let's go ahead and write this in factored form. So remember, instead of just putting an x here like I would if this were a quadratic, because it's 4th power, I've got to put x squared here and here. Then I'll have plus 6 and minus 9. Again, I left this off these examples, but they should say equal to 0. Okay, so we're trying to solve these, so they are equations. I just left that off on the examples. But now we're going to take each factor and we're going to set it equal to 0 to find the x values that make this true and solve them separately. So this one is actually the same one as the last problem. We add 9 to both sides, take the square root. So x equals plus or minus 3. So there's 2 of the solutions. This always tells you, the degree always tells you how many solutions there should be. So one solution is positive 3, one's negative 3. Now we're going to look at this one and solve it. Remember, anytime you take the square root of a squared variable, you always get the positive or negative of your solution, because squaring negative 3 would make it a positive 9 as well. So now let's solve this one by subtracting 6 from both sides. So I've got x squared equals negative 6. I need to undo the square by taking the square root. So x equals plus or minus. I have a negative underneath my square root. That negative tells me that this is an imaginary solution, so I'm going to pull an I in front and then just leave the 6. So 6 is 2 times 3. Those are both prime, so that won't break down anymore. So my other 2 solutions are positive I roots of 6 and negative I roots of 6. Okay. I'm going to just do one more example here. I'm thinking maybe if you would like to, it would be a good idea to pause the video and try this on your own first, and then come back and watch the rest so that you can see if you did it correctly. So the very first step we always want to do is we want to look for the greatest common factor, and it looks like 4 will go evenly into all of these. So I'm going to pull that 4 out front, so that will leave m to the 4th minus 10m squared. And then 64 divided by 4 is 16, so plus 16. Now I can go ahead and factor what's inside here. Remember this 4 out front, I can just ignore it for now, but I'll just put it there on my answer. When I get this in factored form, instead of just putting m here, remember we need to put m squared because my m here is to the 4th power, so when I multiply those out, I need to get m to the 4th. But now we can go ahead and x factor. So if a is 1 and c is 16, 1 times 16 is 16, and then I need to add to b, which is negative 10. So I'm looking for 2 numbers that multiply to 16 and add to negative 10. So I'm thinking 2 and 8 multiply to 16 and add to 10. Again, this is positive and this is negative, so I would need both to be negative. So I'll write this as m squared minus 2 times m squared minus 8. Again, I should have had equals 0 here before we started, so I'm going to put it there now. And now we're going to solve for m. We're going to find the values of m that make each of these factors equal 0. So just set m squared minus 2 equal to 0, and m squared minus 8 equal to 0. Because the 4 doesn't have a variable with it, that one's not going to affect things. So just ignore the 4. If it were like a 4m, then I would want to set 4m equal to 0. But because there's no variable out there, I can ignore it. So now I'm going to solve each of these separately. So on this one, I'll add 2 to both sides. So I get m squared equals 2. And then if I take the square root of that, m is going to be equal to plus or minus the square root of 2. So there's 2 of the 4 solutions. My other 2 will come from this. I have m squared minus 8 equals 0, so add 8 to both sides. So m squared equals 8. If I take the square root of both sides here, I'm going to get m equals plus or minus the square root of 8. And then I just need to reduce and simplify square root of 8 as much as possible. 8 is 2 times 4, and 4 is 2 times 2. So because there's 2 2's underneath the radical, I can bring one out. So m would equal plus or minus 2, and then there's 1 2 that would be left inside. So 2 roots of 2. Okay? So go ahead and give those a try, and we will see you next time.